What do you mean by? Oh, change. The first question is this: why in each input port in a high-speed router we store a shadow copy of the forwarding table? Or in a more general form, why there is a copy of forwarding table in each of the line cards of a router? Why? The answer is easy. In the first generation of network computers, total input traffic to a router are sent to a shared routing table, and at that routing table we try to find the answer, and then the result. This strategy is time consuming. How we can increase the power? Performance power. How? Just by adding information inside each line card, inside of each line card. Okay, just inside of that. To remove those transfer time asking from the main routing table, and also in this case here we have more than one line card. So instead of everything, we can use local copies of routing tables. This is the answer of question number 1. We copy those forwarding table to reduce the overhead times. Question number 2 is all SDA open flow. What do you mean by SDA? Naima, in question number 2, what is SDA? Networking software defined access. I think you mean that is open through the only proposed protocol for software for SDN. I think you are meaning this. Yes? Am I right? Am I right? if you mean that SDO and that OpenFlow is the only used protocol in SDN platform, I should say no. We have some other protocols for SDN. OpenFlow is the most well-known protocol in this category. Okay. Question number 3 in IPv6. What is the function of hex header? Hex header. What do you mean by hex header? Maybe you mean next header. Okay. No. You mean next header? Okay. What is the function of next header? As I said, in IPv6, we try to reduce the overhead, the processing overhead applied to each of those packets. Always, we have something to do in IP packets that which we cannot put them in a standard header of IP version 6. For example, I want to apply some for example, IPsec, some security. Okay, I want to apply some security. But we can see that I cannot put those information, those encryption information inside what should I do with those information? I cannot put them in the standard header of IPv6. It's simple. Put them as a next header. Oh, excuse me. Put them as a next header. Or, for example, in IP version 4, we said that the length of a header in IP version 4 is a value between 20 to 64 byte. Why? Because we have some options in IP version 4. If I apply those options into a header, the length of header would be extended. In IPv6, we cannot see those options. We say that in IPv6, we put those options as next headers. It means that router, you can handle these steps or simply passing them. Okay. So instead of need a header with variable length, same as IP version 4. We put those information, those options, those extra information as a next header in IPv6. And what is important is that those next header are standing after the first 40 bit. We know that the first 40 bit is a header of excellent here. They are placed in the first bytes of payload. We have a fixed 40 bits, and those extra headers are inserted into the payload. So we did it to make a simpler process. Okay, Naima? You're welcome. Is there any question? Any question?